universities to
So, hello everyone. Thank you for coming, and thank you for everyone online as well. Tonight the talk we have is a talk from IMC, one of our top sponsors, and tonight we have Hamish Cook, obviously from IMC, who's flown up to Sydney today to talk to us about, well actually he's giving a technical talk on writing code that works fast in a fast way. So, Hamish is going to talk to us about what it's like being at IMC, what kind of work you can do, and teach us about some of the things they do at IMC. If you have any questions about what it's like working at IMC or during the talk, just pop it in the YouTube chat or throw your hand up, and I'm sure Hamish will be more than happy to answer it. But apart from that, thanks for coming, and I'll let Hamish go start.
Awesome, cool, thanks. So yeah, my name's Hamish Cook. I work at IMC in Sydney, and I'm very stoked to be up here at UQ, because UQ is one of our favourite universities. I'm not picking favourites, but so yeah, I've been at IMC for 4 years now, and I started off in the hardware team because my background is in electrical engineering, but I've sort of moved into software, and I'm doing a lot of software hardware interaction stuff, which I really enjoy. So first question then, who is IMC? Because I think a lot of people don't really know, and so I thought it's worth spending a couple of minutes just getting an idea of what IMC actually does. So the first thing to understand is that IMC is a trading firm. Now, I had questions in the past in similar presentations asking what trading actually is. So I thought we'd just spend a couple of minutes going over it. So trading is actually really simple, and you'll probably find yourself doing it all the time. It's when a seller has something they want to sell to a buyer, and the buyer will generally pay money for that thing. Now, in financial trading, we trade what are called financial instruments. But under the hood, they're just items that people wanted to sell, other people are wanting to buy, and those are traded for money. So what is a financial instrument then? There's actually quite a few different types of financial instruments. So stocks, obviously the first one that most people think of. So shares in a company, BHP, Google, Microsoft, things like that. Bonds are another one. So at IMC we don't trade bonds, but there's huge bond markets out there all over the globe. And they're generally how government raise money, for example. It's how they're get loans. Commodities are another one. So oil, gold, things like that. Those are other things that you can trade on financial markets. And the final one, and the one that's actually most interesting, are derivatives. Now derivatives derive their value from another financial instrument, which creates these really interesting relationships that IMC love to discover and then use to our advantage. So IMC actually is really good at options trading, and they're a type of derivative along things like futures. But we also do futures, and we also do things like stocks as well. So at the moment, we're still missing someone from the equation. So we've got a seller and a buyer, but the one thing we're missing right now is the exchange. And this is where all the trading actually occurs. So all the buyers and sellers are going to the exchanges, and that's where they'll meet each other. In fact, the exchange actually meets the buyers and sellers themselves. So you don't actually go out asking for a particular buyer if you're a seller. You'll tell the exchange, I'm wanting to sell something for X amount of dollars. And then its job is to go and find a buyer for you. So what does an exchange look like? Well, it's actually not that complicated. It's just sort of a bunch of different areas within the exchange where, in one place you might have Google that you're trading, in one place you might have Tesla that you're trading. And then maybe oil is another thing that you're trading on the exchange, all in different parts of the exchange, different areas. And S&P futures, that's an example of a derivative. So the S&P is an index in the US, and you can buy futures of that index, or buy and sell futures of that index. So that's a type of derivative. But again, we'll just find it as another area to trade on the exchange. So I've put here as a buyer and a seller kind of the image of a person, but that's really not how trading is done these days. The days where people are yelling out in the pit, calling orders and all of that, those days are essentially gone. There's a few places in the world where you find them, but they are mostly gone. It's all computers. Computers are the ones doing the trading. Now, obviously, it's people controlling the computers, but it's computers that are the ones that are sending the orders to the exchange, which again are running computers, and then talking to buyers and sellers, connecting them up. So when you think of an exchange or financial trading, think of racks of servers over people yelling in a pit. And then finally, who is trading? So obviously IMC is trading. This is a picture of an exchange here. But there's plenty of other people trading on the exchange. So we've got lots of other participants, and it's the exchange's job, as I mentioned before, to match up the buyers and the sellers. All right, so then how does IMC trade? So most people, when they think of trading, will think of, you buy something when it's cheap and the price goes up, and then you sell it and you make lots of money. You'll sell minus buy and you hope that's a positive number. That's actually, well, the sell minus the buy being a positive number is what we're trying to do. But the whole goal of buying something and then waiting for the price to go up in 6 months is actually not what IMC does. This is not how IMC trades. So IMC is a market maker. My apologies. I was going to play a video, but I think we'll skip over the video due to the audio issues we're having. But the key there is that market makers rely on extremely up-to-date information from the exchanges to make financial decisions, and they provide a market for buyers and sellers who are also trading on the exchange. So we're not there to buy something and then squirrel it away and then come back six months later to sell it. We're constantly there buying and selling on the financial exchange, and hence the name market maker. We're making markets on the exchange. We're providing what's called liquidity. So we'll skip over that one. So yeah, IMC is trading financial instruments in order to create a market. We don't actually hold opinion about the value of things on the market. So we don't think, oh, this thing is going to go up in 6 months, let's buy it. We don't actually care whether it goes up in value or down in value, because the goal is not to hold on to it. The goal is to trade to make a market. What IMC is really good at, and what we care about a lot, is mapping the relationships between the different financial instruments. So I mentioned before we've got derivatives. So we really want to know how the different derivatives are all related to each other, and then how we can leverage that in order to make good trading decisions. So that might not explain why we need to be fast. The thing is that markets are always moving. There's very few financial instruments, especially ones that are very interesting, that just sit still and do nothing. Like if nothing's happening on it, then no one's really buying or selling, because there's not much point to that. So what we're interested in is mapping how markets move and how different financial instruments change in value. And they're doing these constantly, all of the time. And if you're basing your financial decisions off old information because you're really slow, you're going to be making really bad financial decisions about how you're trading. So you need to be incredibly fast on these financial markets, because if you're not fast, someone's going to beat you to it and then take advantage of you. So our job is to be as fast as possible. All right, so let's zoom in a little bit on what it means to trade on a financial market. So we've sort of given you the 50,000 foot view. Let's go down to 30,000 foot view. So we have an exchange, and we've got us as a participant on the exchange. So the question about like how fast do we trade, I think is better to flip around and say like how fast can we trade? Like what are the limits to how fast we can trade? Like where are some of the easy wins that we can get? And so I think it's worth looking at exactly like how we actually trade on the market. So we've got an exchange, we've got IMC. The exchange is sending what's called feed. Now feeds are a bit of information that is an event that's happened on the exchange. It might be that someone's added an order to the exchange. It might be that a trade has occurred. It might be that someone's deleted an order on the exchange. And that will get sent to IMC, but also get sent to all of the other participants. And then given that information, given the order or the trade that we saw, we might send an order of our own. So what we're doing is responding to an event on the exchange. And that loop there is like the critical part that we need to keep as fast as possible. Information from the feed through to the order. So let's zoom in a little bit more. So we've got an exchange. Inside an exchange is what's called the matching engine. And this is the thing, the server that's essentially matching up the buyers and the sellers. So is it saying, do I have a buyer that's willing to buy at a price that some other seller is willing to sell at? And then on our systems, we've got lots of trading servers, trading different products or different financial instruments, things like that. And in the middle, we've got the internet. So as I said before, we've got some feed. It's coming out of the matching engine. It might be, there's a trade that's occurred and it's interesting to us. So it's going over the internet into the IMC sort of wider system. From there, we've got some switches, and the switches will fan out that information to all our trading servers, the individual servers. And then once we've got this is all over the network, by the way. Once we've got that, we've got a network card, which is actually having to receive the information from the network and turn it into something that software can actually understand. Now, above the network card is what's called the Exchange API. Now, this is how we decode the information that comes from the exchange. So all of these exchanges are slightly different to each other. They all have different ways of describing an order or describing a trade. And so we have to decode that information from the exchange and turn it into something that we can understand. And then above that is our trading system. And this is the guy that's making decisions and deciding whether to send an order in response to that feed. Now, once we've got a decision is made, once we say we want to send an order, it's pretty simple. We send it back out over the internet back to the matching engine. Now, the critical loop, as I mentioned before, is this red line. So from the matching engine over the internet, into the switch, through our trading system, and then back out over the internet. Now, our job is to get that line as short as possible. And there's very few things that we're not willing to do to try and get that line as short as possible. So let's focus on one part of the system for a start. Let's just have a look at the internet. So let's try and figure out what kind of impact the internet is going to have on our little red line. So maybe just using a banana for scale because it's kind of fun. How fast does light travel in 1 second? How many bananas can light travel in 1 second? So if you had a bit of light and you started it and you lined up some bananas and then you stop the stopwatch, how many bananas can it travel? The number of bananas it can travel is about 2 billion. So that's quite a few bananas in 1 second. So then another question to ask then is how many CPU cycles can light travel in 1 second? And the answer to that is actually about half a banana. So in one CPU cycle, light will travel at max speed about the distance of half a banana, which is crazy. Like normally we think of speed of light being this incredibly long thing. It turns out it's actually not. In the terms of computing, light is really slow. So maybe some of you might be seeing the problem that we're getting with using the internet. So then, how many bananas is it from Sydney to Tokyo, right? If we lined up bananas from Sydney to Tokyo, how many bananas is that going to be? So I did some back of the napkin calculations, and it's about 90 million bananas from Sydney to Tokyo in a straight line. Remember that the internet isn't always a straight line, right? It's going to be, if it's a fiber cable, for example, it's going to be winding its way all over the continents to finally get to Tokyo. So it's going to be significantly more than that. So then the next question, the final question is, how many CPU cycles is it from Sydney to Tokyo? How many CPU cycles will tick by in the time it takes light to get from Sydney to Tokyo? And the answer is about 180 million CPU cycles, roughly, give or take. So that's an incredible number. And another way of putting it is, if you have an algorithm that you think you can speed up by 1 CPU cycle, it's easier to just move your server a quarter of a banana closer to the exchange than it is to speed up your algorithm by 1 CPU cycle. Remember, it's half a banana, but you've got to go there and back again. So just move your server a quarter of a banana closer to the exchange, and you've done just as much work. So as you can see, like having our servers in Sydney and then talking to Tokyo, this is like a terrible idea. So this diagram here, I kind of lied to you. This is actually not what we do. It's what none of the participants who are market makers are doing. What we actually do is we locate our servers inside the exchange. So market makers are a kind of very special participant because we're not trying to just buy things when they're low and sell things when they're high. We're providing liquidity to the exchange, and the exchange actually want market makers to come along. They actually provide rooms, and you do have to pay for them, but they provide rooms where market makers can set up inside the exchange. And this gives us like the smallest number of bananas between our servers and the matching engine. And we actually do try and cut the size of our cables down if we can. Like, we actively make sure our cables in our data centers are as short as possible. Because as I said, all it takes is 1/4 of banana to equal like removing one cycle from an algorithm. So we spend a lot of time on that. So yeah, this is actually much more similar to what a trading system might look like. All right, so let's just look at a trading server and what actually takes place. So we sort of glossed over what happens inside a trading system. So as I mentioned before, we've got a network card and we've got a network API. So the network card is a hardware thing, the network API is a software thing. And this is how we sort of talk to, or how we get information from the hardware in software. So we get feed, and that comes into our Exchange API, which, as I mentioned before, is decoding and encoding information from the Exchange. From there, it goes into what's called a market data processor. Now, this guy's job is to figure out if the bit of feed that's just come in is interesting or not. Some of the feed you get from the Exchange, actually, we don't really care about, and we can just throw it away. Other bits are really important, and we can flick it on to our next guy, which is the opportunity checker. Now, as the name suggests, this guy's looking for opportunities in the feed. And this might sound quite straightforward, right? But trying to figure out if an opportunity is there can be extremely complicated given what we mentioned about relationships between financial instruments. So you can have one input like generate thousands of opportunities for different products that we have due to the way that derivatives work. Opportunity checkers are where we spend a lot of time optimizing. And one of the things that we try and do is pre-compute things ahead of time, so that when we do get feed, we can simply say, you know, look up what we should do when this bit of feed gets here and take that action, as opposed to like try and map out, well, how all these relationships work and what's the end result. The next guy is the order processor. So the opportunity checker might have decided that we want to change our exposure in the market, the orders that we have sitting in the market. And it's the job of the order processor to figure out what orders we need to send to the exchange to make what the opportunity checker has described a reality in the exchange. So we might have orders that are currently sitting in the exchange, and the opportunity checker has decided, actually, I don't want them there. So the order processor might also have to send deletes for certain things. And then it might also have sent other orders, so the price might go down. For example, we might want to add an order at the top and delete orders at the bottom to move our orders in the market down. But it's the order processor's job to figure out what we need to do in order to respond to the opportunity checker has actually figured out. Now, final part, and one of the most important parts, is the risk limit manager. And this guy, his job is to make sure we don't do stupid shit. So his job is to make sure that any orders that we get aren't sort of out of bounds. You know, if we've got a software bug, we're adding zeros. Is that within the bounds of what we're expecting the order price to be? If it's not, then the risk limit manager can kill an order at that point. The other thing that the risk limit manager is required to do is meet certain obligations that we have to trade on the exchanges in different countries. So it's actually a non-optional thing to have. The regulations for trading on these exchanges require us to have this guy. And then finally, once we know it's a good order, we can send it out to the exchange through our network card. Now, the one other thing that we want to do is we want to know what we just did, right? So at the moment, like, we've sent something out, but we haven't actually, you know, written down what we've just done. We don't know what it is the order we sent. So we also got what we call an order logger, and that's just sitting on the side. Now, this guy can actually, the order logger stuff can happen after we actually send the order out. Like, this is going to happen way after that, because it's not critical that it happened beforehand. We need to know that we've done it, but we can put it after we actually send the order. And this is one of the tricks we can do, right? But yeah, again, this loop here is the one that we're trying to limit. So this is like our internal latency. And this number here, from in to out, is what we call our wire to wire. So the wire being the cables that we plug into the network card. And so wire in to wire out. Like, how long does that take? And that's a very critical number for IMC. And any other market maker trading. All right, so what are some tricks to actually making fast software? Now, the first one is to know your hardware. So it's all very well to like try and write fast software, but if you do not understand how your hardware works, you're not going to be able to achieve it. It's practically impossible. So it's really important to understand how your hardware works. How does caching work? How does main memory work? How does PCIe work? because this is most likely the protocol you're going to be using to talk to your network cards. So it's really important to understand how the hardware works. And this is one of the reasons why I love what I do, because trying to understand the hardware and trying to understand the interaction between software and hardware is like super fun. And it's where you get some really amazing discoveries. Second one, measure the right thing. So a lot of you may have like tried to bust out little micro benchmarking thing where you like sit in a for loop and you might count, you know, how fast it is to run this little algorithm. Now for us, that's actually very deceptive. The system as a whole is the one that you really want to be measuring. So the wire to wire is the most important number, and micro benchmarking, maybe it can help you in some circumstances, but wire to wire is king. So make sure you're measuring the right thing. And finally, use the latest toys. And this is one of the, again, real fun parts. We're using the latest compilers, the latest like CPUs and FPGAs, and all the latest toys we can get our hands on. And this is like incredibly fun. We get to really play with the latest toys. Okay, so then maybe we'll go back to our original question. Who is IMC? Well, IMC is a tech company. So we do trading, but it's a technology company that's doing trading. Like we base our entire systems on technology. So I think calling IMC a trading company is misleading to people who are sort of in the technology field. IMC is a tech company. And so yeah. Right, so the next part of my sort of chat is going to be, so we've covered how do we make fast software, but the other side of that is like, how do we make software fast, as in how do we rapidly get stuff to market? Now, again, it might not be like obvious why we want to be doing that, and there's plenty of companies that have extremely long times between where someone's written code and where it's going into market, and they might be fine if their products aren't changing a lot. But for IMC, we can't do that. An idea is not making money, it's not trading and doing productive things until it's in production. So our job is to try and get the code that we write into production as fast as possible. And you can think of the money that we don't make from having an idea that we haven't got into production as like a loss. This is money that we could have made, but we didn't because we didn't get an idea into production fast. And so we want to minimize this loss, and we want to come up with systems to help us minimize this loss. Okay, what is the process of getting an idea into production? Okay, so you've got an idea, that's great. Collaborate. And this is one of the really important things, and one of the things we love doing at IMC. We really love collaborating with different people, getting different ideas and different like experience from other engineers and other people, because they might have a really different take. They might have tried this before and figured out what doesn't work about it. So collaboration and the idea sort of really go hand in hand. Then obviously we code, and okay, we're good, right? All done. So, right, where am I taking this presentation then? So I'm not going to try and cover the first 3 points. This is something that one, hopefully uni's going to help you with, but two, it comes with experience. Working in the industry, you'll get better at some of this stuff. So what I'm actually going to focus on is the last part, the success part. So for you guys, this might not be, again, super obvious why it's a problem. So you might have, you writing a uni assignment, and in order to check that it works, in order to run it, you just run it on your laptop. You might have an IDE, you push the play button, cool, all right, submit. For us, we've got different scale of problem. So we've got hundreds, or I shouldn't say hundreds, we've got probably 100, no, probably more than 100 software developers over the globe, and we've got, in often cases, single repositories where our code is going. So we've got 100 developers, and then on top of that, our servers are located all over the globe. So we've got servers in Japan, exchanges in Japan, which is where I work, Korea, Hong Kong, the US, Singapore, you name it, Amsterdam. So we've got servers all over the globe. So the job then is how do we get the software that we've just written, onto the servers that are located all over the globe? And how do we do that without breaking everything, making our servers catch fire? So that's our job. We're going to cover the race to production. So the first step for this is code review. So you've written code. First step is to get it code reviewed. Next step is version control. So we drop it into version control. Finally, we build the software, and then we deploy the software. So simple, we'll go over the steps one by one. All right, code review. So Harold is currently showing off his code. So why did we do code review? I'm kind of going to quote Wikipedia here because I think it has some really great examples. The first thing to note though is code review isn't to find bugs. We're not using code review to find bugs. We're not getting other engineers to look over our code and see what's wrong with it. That's not the job of code review. We might use the other engineers to look at code and say, look, is there a better way of solving this problem? I think that's one of the primary reasons, primary objectives of code review. Can we see a better way of solving this problem? Again, it's about collaboration, about getting different people's ideas and takes on things. Another part is like knowledge transfer. So you've just written code in some corner of the code base. Like, how does any other engineer know about it? We don't want a system where like, oh no, we can't touch that code. I know nothing about it. The only person who knows about it is that one guy who's over in the corner there. We don't want that. We want like everyone to understand roughly how the code works. And so code review is a big part of that. And that ties in with the next part, mutual responsibility. So everyone is responsible for the code base. If there's a bug, it's not just like, oh, we'll have to wait till Joe comes in. No, you go and fix it. It's our code base. It's no one person's code base. And then finally, and this again is a surprising one, there's actually a couple of exchanges out there that require us to do code review. We're not allowed to take the code and the builds and stuff and put it into production until it's been code reviewed. So yeah, the requirements the regulations require us to do this. All right, so what does it look like to do a code review? So first you upload your code to a code review server. Next you invite some of your colleagues, one or more colleagues, to come in and do the code review for you. Once you have that, you wait for a response from your colleagues. Maybe they found something that you didn't do right, so you go in and fix the code, and then you go around the circle again. So you re-upload it, you've already invited them, so you don't have to worry about that. Now you wait for responses, you're all good, and you finally can submit your code. So this is the code review cycle. Now, this is really great, but I would guarantee you if you did this, you would still get a lot of bugs that will go into your software. Because again, humans aren't compilers, they're not, machines. They can't look at a bit of code, run it in their brain and see that there's any bugs. So a big part of the code review process is also writing tests. So we do a lot of tests at IMC, we're writing a lot of tests, and that's a big part of the code review process. So if the test fails, that's equivalent sort of waited for a response, and you might have to fix something to get the test passing again, and you go around the circle again until test passing and you've got a green light from your colleagues. All right, so first part, code review. We use a system called Gerrit at IMC, but there's plenty of other options for doing code reviews. Right, next step, version control. So what's the motivation of version control? Now I remember when I was at uni, we just had a folder and you would dump software in it, and when you're finally ready at the end of the day, you might zip it up and send it to the supervisor, and that was it. But again, for like 100 developers all trying to do work, that just is not going to fly. So what we use version control there is to try and manage the changes that are going into our repositories, our code bases. The code that goes in are grouped into things called revisions, and those revisions are atomic. That means that at any point you can go back and look at any revision and it should pass all the tests and it should be having a green light from the reviewers. It also means that if something goes wrong, so maybe someone submits some code, a few other people submit their code on top of it, and then later on we find out actually that code, that revision back there was broken. We can actually reverse it. We can go like, take the inverse of that revision, apply it on the top, and it's very easy for us to like revert a code change. And that really helps us when we're doing cross-office work as well. So say someone from Amsterdam, say I submit code with a bug in it, I got home for the day, and someone in Amsterdam comes along, tries building something, it doesn't work, they can very easily just go revert on my code without having to wait till I come in the morning. So version control is a really important part of this process. And we use Git along with like essentially everybody nowadays. There used to be a few options a couple of years ago, but Git essentially is the only option, it's an only option for a good reason. It's a fantastic piece of software. So I would encourage everyone to get very familiar with Git because it's like a practical certainty that you'll be using this in industry. All right, so Git, next step. Right, build. What does that mean? Okay, so this is a piece of C++ that I wrote. Why would this not work? Why would this not run on a computer that we have, or any of our servers, and print out hello world? Well, the reason is that computers don't understand this. They do not know what this is, these characters that are in this weird order. What we have to do is turn it into that. So this is what a computer understands. This is machine code. Hopefully you guys are familiar with this. And you can see up the top, ELF. So this is a Linux binary that we can run on a Linux machine. And what do we use to build? That's the job of the compiler. So the compiler's sitting there and it's taking the code that people have written and turning it into machine code that can be run on the machines. So what are the different options for compilers? So one of the big ones is GCC. Now this is an open source solution, but it's a fantastic compiler and probably better than many of the closed source solutions out there. Clang is another one, again open source. Final one is Microsoft. Those three compilers, at least for C/C++, probably take 95% of the market for compilers, probably more. Microsoft, though, is a closed source one, so we can actually see how it's written. All right, okay, so we know how to build our code. We can use our compiler to do that, but we don't know when to do the builds, like where do we do the builds? We're just building them on our local machines and then like deploying them to the 100 servers. Like, how are we taking code that we've written and turning it into a binary that we can then publish out? So that's the job of the build service. So we've got a server that's sitting there to manage all this for us. So the build service will get some kind of trigger. Now we'll get into what trigger might be later, but it'll get some kind of trigger. And that trigger will kick off the build agents. So the build agents are the ones that are actually doing the builds. These are the ones that have installed GCC or Clang on them. And the build service will essentially tell the build agents, can you please build this software for me? Now once that's done, it reports the build back to the build service, and that will push the build into what's called an artifact repository, which is essentially just a giant database for all the software that we have. And we can periodically clean it out. We can set rules, don't keep software that's more than 30 days old, but then in other cases we might want to keep it for years and years. It might be a requirement of the exchange that we hold on to the software. So yeah, again, it depends on the exchange and our use cases for what we do with the builds. But this is probably what many big organizations will use for doing builds. So what do we use? What solutions do we use for doing our continuous delivery via the build service? We use a piece of software called TeamCity. Now we're using GCC, as I think I mentioned before. And then once those builds have been reported back to TeamCity, they'll be stored in an artifact repository called Nexus. All right, so this has answered a few more of our questions. But I didn't really go into the triggers, right? So we know what happens once there's a trigger, but I didn't go into triggers. So what are some triggers that we might have? Well, the first one, and a really nice one, is anytime pushes something into Git. So anytime anyone does a push into Git, boom, it kicks off a build, and we have a build for every separate change in Git. And that's really great in cases, especially where there's not many people pushing. Because then you any point you can grab a build with that version associated with it. But it doesn't really necessarily work when you scale up, unless you've got a very big budget to buy a lot of build agents. So often what you might do is put it on a timer. Say maybe build once an hour, or once a day, or once every few hours, or something like that. So that's another common way to do it. And maybe you mix and match. There might be some stuff that doesn't take long to build, and so you build it for every release, every time anyone pushes anything. But for other big bits of software that might take half an hour to build, maybe you only build it once an hour. And the final one is manual. And so if someone makes a change that they really want to get in, but it's on a build timer, maybe they can just go, all right, just build whatever's at the head now. And that just gives the developers a bit of flexibility, but it doesn't take away the ability for us to use the build service. So this is they're kicking off a build, but they're kicking off a build on the build service. So we still get the safety of the build service, even if someone wants to do a manual. All right, so what does IMC look like? All right, so we've got our code review. We're submitting stuff into Git. That's kicking off a build on TeamCity, ideally. So we're assuming here that we're, every time someone submits something into Git, kicking off a build. That will kick off the build agents. So the build agents will then report their build back to TeamCity, and finally that gets dropped into Nexus. So that's really great. So anytime anyone has a change, boom, you get out with a nice build at the end on a reference system that we know is in a good state, without being someone's local laptop that doesn't have build on. So yeah, as I was saying, build is TeamCity. Now the final part is deploy, and you might think, again, this might be easy, right? We've got all the builds, you just push it out. What's stopping us? So yeah, just deploy it onto the IMC servers. Well, that's actually really complicated, and it's sort of, there are some places, I think Google's trying to do like a very like CI/CD system where like every build is updated to push immediately, and it's constantly updating these microservices anytime anyone makes changes. We can't do that. We can't just stop trading in the middle of trading, like hours, and then like update a system and then bring it back up. We have certain requirements as being part of a market maker. Some of those include a specific uptime. We have to be running and providing these services, the market maker services, for like 99% of the time. And we might get bugs that bring down our trading system. That's our job to get those up back really quickly. But anytime someone makes a change, we can't just push immediately out. There might also be like regulatory requirements. So again, the regulators might say, you have to meet certain checks. You might have to test it on a test market before that you actually deploy it to the real exchange. So it can be like quite a job to go through deploying stuff in some exchanges. And the thing to remember that if you find a bug at this stage, it can be like really, really bad. Often these bugs are like really hard to find, otherwise we would have found it through the testing or the code review or many of the other build steps that we've got. So if we've got a bug at this stage, it can actually be really difficult. One, it can have catastrophic consequences, and two, it can be really hard to nail down. So you really don't want to like just push stuff out as immediately after it's built. You might want to do some further testing, for example. So for the deployment step, we sort of have quite a custom IMC style thing. And yeah, I'll leave it at that before I put everyone to sleep. But yeah, this is sort of an overview of how we at IMC both write software that's fast and also write software fast in a quick way, and do it safely. So what I am going to do now is just do a quick talk about what opportunities there are at IMC. We've got a few roles available if you're interested. So we've got some summer internships. You can see the pay packages are quite nice, and a graduate program as well. So we love getting people in for the internships. We think it's a really valuable experience. Sure. Yeah, what was the question?
What year level do you need to be to apply for a summer internship?
The internships, we prefer you to come in like the summer before your final year. But if that's not the case, as in you're like graduating at the end of the year and you want to get a role at IMC, like there is the graduate program. But I would really encourage anyone who's still got like a year and a half left to apply for the summer internships, because they're like a huge amount of fun. We like genuinely get people to do interesting projects that we often push into production. This is not just like some stuff that we get people to write and then throw away. So I worked with some interns a couple of years ago, and this is like a critical part of our trading system now. So we really do get you to do some really interesting projects. So I would encourage anyone who's thinking about applying for an internship to really go ahead. And again, graduate program if you're sort of in your final year now. But yeah, applications close 31st of May. So yeah, get it in quick. So these are sort of some of the requirements that we have. I'm not going to go through it all because we'll be here for half an hour. And I can put this up if anyone's got specific questions later. But hopefully none of them are particularly surprising. So the recruitment process, it can be quite in depth. So there's actually quite a few stages to the recruitment process. But what it does mean is that when we give our offers at the end of the day, we're really sure we've got the right people. So although you might, if you do apply and find it frustrating, there's quite a few stages, just know that when you get an offer, we really, really do want you. So don't be put off by the sort of in-depth process. And yeah, so, but yeah, yeah, and often we actually do fly you down to Sydney as well. So if you're applying and you get through to sort of the super day at the end, you get flights down to Sydney, you get to hang out with us and answer some interesting questions. So yeah, maybe we'll see you in Sydney. The final thing that I'll just cover is IMC LAUNCHPAD. So I don't really know the full details of this. I can potentially get Ellie to come in and explain a bit more. But the LAUNCHPAD stuff is the pre-penultimate, so I think if you've got another 2 years left after this, we'd love to see you at the IMC LAUNCHPAD. So this is really trying to get you a step up when it comes to maybe the internship or the grad positions. So it's an incredible program that we run, and Ellie has done a really great job at that. So yeah, have a think about it as well. So we've got some stuff for if you've got 2 years left, 1 year left, and no years left. So yeah, really consider applying if you're sort of eligible. We'd love to see you in Sydney. So yeah, I will leave it at that. Thank you everyone for your time and attention. I'm very happy to answer any questions. I love answering questions. So please fire any questions that you might have at me and I'll see if I can answer them. Yeah?
I was just wondering, what degree did you study and what sort of made you want to get into trading?
Yeah, that's a good question. Okay, so I studied electrical engineering and I did that at the University of Canterbury. I really enjoyed the FPGA part of my course, and one of the things that I do a lot of at IMC is FPGA work. So I'm not writing the hardware, the hardware description language stuff that gets programmed onto our hardware, but I work very, very closely with the guys that do write that to try and make our system as flexible and as powerful as possible. And I really enjoy those problems, which is one of the reasons why I love working at IMC and I wanted to work at IMC, because we've got a quite a deep stack of software. So we've got quite slow software at the top that's making very smart but slow decisions. But these are doing some of the pre-computations, for example, and those pre-computations will get sent to some of the faster but dumber things. But dumber, as I was saying, means fast. And then at the very bottom of that is the FPGA. And that's really dumb but incredibly fast. And I really love the challenge of trying to untangle the logic and figure out what we put in hardware, what we put in software, how we can make those trade-offs and really make things work as fast as possible without losing the control we have over the system and the smarts that go into that. So I really love that challenge, and that's, yeah. Cool. Any other questions?
With the market maker thing, that's, say you've got a 10-cent gap between buying and selling.
Yeah.
You're, based on the opportunity checker, you're buying say at 5 cents, buying and selling at that.
Exactly. So we'll sit there in the market and provide orders at the bids and the offers, and then people will trade with us.
Okay.
And so the part of the reason we need to be fast is that we've got lots of orders that sit in the market that are providing this liquidity, as we call it. And if the price of that financial instrument changes and moves up, for example, we need to move really fast to that. We need to pull those orders that we had at that top level so that someone doesn't come and, pick us off.
That makes sense.
And so we need to pull those orders really quickly, but then also we need to get in really fast and place those orders in the new sort of top level at the bottom end. So that, because often exchanges, to prioritize the buyers and the sellers, they will prioritize who got there first. So if you're really slow to add those orders back into the market, then no one's going to trade with you because they're going to trade with all your competitors who've gone there really fast.
Yeah.
So that's part of why it's really important for a market maker to be fast on the ball. Yeah,
Makes sense.
great question, mate.
Thank you.
Yeah.
We just got a question from the chat here. So, will the summer internship accept people with no prior experience, and if they're an international student?
So international students, I don't know the full details. I would encourage that person to like get in contact with recruitment. I know that in some circumstances that we do. So for example, New Zealand, we will take interns from New Zealand. I don't know outside of that, unfortunately. But we do have some requirements for that. So we expect you to be doing like computer science or electrical engineering, for example. And your high school results will play, and as well as your university results so far, will play a part in sort of figuring out who gets through to the latter stages of the recruitment process. So we do kind of expect strong results. Yeah.
Does that mean you've got a higher preference on high school results than university, or is it much the same?
It's a bit of both, I think. Like I'm not fully familiar with that part of the recruitment process. I would say that your like the most recent results are going to be the most important, but generally sort of the high performing people are going to have pretty solid results from both high school and university. They generally track each other, generally speaking.
So
Yep.
if you're setting up an exchange, would you set up an office in that country? And can you travel between those offices?
Yeah, so again, great question. So yes, in some circumstances we do. So we have 3 main offices. The head office is in Amsterdam, so we're actually a Dutch company. So our head office is in Amsterdam. We have an office in Chicago, where the derivatives exchange is located. So when most people think of financial exchanges in the US, they think of New York, the New York Stock Exchanges and all the things there. Well, that's where all the stock exchanges are, but the derivative stuff is all in Chicago. And some of you might have heard of like the cable that they run between New York and Chicago that like they shave a nanosecond off and people charge millions of dollars and blah, blah, blah. But that's the reason why. So the stock exchanges are located in New York, and then derivatives exchanges in Chicago. And as I was saying before as well, like the changes in the underlying stocks will affect how the derivatives trade. So hence the cable. But yes, back to what your question was. We have an office in Chicago, and then we've got one in Sydney. So we generally don't, we'd prefer it if we didn't get applicants who are like applying at IMC with the intent of moving to Chicago. So IMC Sydney with the intent of moving to Chicago. Like if we're looking to hire you at IMC in Sydney, for example, we kind of want you there, like in that office. I think if you were interested in like moving to Chicago or Amsterdam, like in the long run or even the medium term, have a chat to recruitment. They might be able to like connect you with the other offices where there might be other opportunities there. But that doesn't mean that you don't get to travel. So I've traveled to both the Chicago office, so part of the grad training that we actually spend a lot of time and effort on, we fly you to the other offices. So you actually, the first thing you do when you come in is they're like, send you on a plane to Chicago or to Amsterdam. And it's really fun time. There's like a lot of training, but you get to meet like all the other people who are starting at the same time as you across all the different offices. So you really get to build some great relationships, which is one of the reasons why we do it like that. So yeah, you do get to travel. I've also traveled for like after I started, so I did a project that was applicable to the other offices, and so I traveled to Amsterdam to sort of explain what I was doing and how it might be applicable to them. So if there's a good business case, then they're keen for you to travel. Yeah. So, yeah.
I may have misheard earlier, but did you say you worked in Japan for a little bit?
Ah, sorry. Yeah. So this is. I work on the Japan desk. So we trade the Japan exchange from Sydney. So we have our servers, our trading servers, sitting in the exchange in Japan, but they're controlled from Sydney. So we have like quite high level APIs, nothing like buy and sell from Sydney. We'll give it like very high level instructions, what kind of risks we want the system to take, like how aggressive we want to be, how defensive we want to be, and we'll program those like configuration to our servers, and the servers will do the automated trading for us. So we in APAC, the APAC office is in Sydney. That covers Japan, Hong Kong, and Korea. So yeah, if you do come to work for us, you'll be trading one of those desks. And yeah, I work specifically on the Japan desk. So I focus on making our connectivity with the Japan exchange as effective as possible. Do we have any other questions on the stream?
I think Ellie's answering this one.
I do have another one, actually.
Sure, yeah.
Some companies look for specialized fields in computer science, like Google looks for people in program analysis and things like that. Does IMC look for people in any specific fields, or have any wants, or is it really just algorithms and hardware people?
It's general. So we focus more on getting smart, driven, intelligent, curious people that we can sort of like set loose on any of the problems that we have, as opposed to like trying to find a particular person with a particular set of skills. Yeah, anyone who's just got a drive to learn, that's like, I mean, I do a lot of interviews, and that's always the sort of top thing I'm looking for. I don't even look at CVs myself. There's other people who do, so I don't want to try and say that it's not important. But once I'm interviewing someone, I'm looking for curiosity, for drive, for like, you know, I couldn't put a problem down. I couldn't sit still until I'd solved it. That's the kind of people we're looking for. Yeah, and then yeah, once we've got those people in, we can then train them up in the kind of areas that we need them to be. Yeah.
I was just also wondering how, like, because you talked about the opportunity finder part of
Yep.
your system, that would, I assume, producing that would be done with quite close collaboration between the financial sort of trained people and the software sort of trained people.
Absolutely.
How
Yeah.
does that work, and do you value like financial knowledge in your software engineer type?
So we have. So I mentioned that I'm on the Japan desk specifically. So I'm in Japan execution. So my job is to work at like connecting our trading systems to the Japan exchanges, and it is very beneficial to have a good understanding of how financial systems work. But there are different areas in the company that require more in-depth understanding. But in saying that, like, as sort of tying back to what I was saying previously, we're much more keen on getting people who are like curious and driven, and then we can like teach them what they need to know about the financial system. So it's great. We'd much rather see someone have a real interest in the finance system but doesn't really know much about it than we would to see someone who thinks they know everything about it and has got nothing to learn. Like, that would be a negative. Like, we would not want that person. So a real interest in this is very helpful over having actual concrete knowledge. Yeah.
Would you say, going off that, just back to the ATAR equivalent results and stuff, would you say someone who started off with poor grades, say at uni, and then ended up having a distinction average, would you say that shows signs of like drive to learn? And
So I don't know what our cutoffs are, if that makes sense. I don't even know if we have a cutoff in that way.
yeah,
I prefer to not look at candidates like that,
yeah,
because once the candidates sort of get to me in sort of the interview process, again, I'm looking for people who are driven, as opposed to people with good results. But I don't know the sort of underlying expectations we have. If you're really interested, really go and have a chat with Ali or any of our recruitment team. They're like super awesome people and would love to hear from you and answer questions. So, cool. Do we have any questions in the back?
Well, with that, thank you, Hamish, for coming out,
No worries.
flying up here. That's a long journey to come for a talk, but we appreciate it nonetheless. So we actually have a token of our appreciation as well. You get a mug,
Oh, that's cool.
probably buy a million of these, but here's one for free.
That's
So,
awesome.
Thanks for coming out
Thanks
to
very
the
much.
talk, and maybe a quick round of applause for Hamish. So we have some pizza outside as well that we're going to chow down on now. But apart from that, thanks for coming, everyone. IMC is sponsoring our CodeJam on Saturday. So that's one of our flagship events for the year. You come along, you get some practice doing kind of questions you might see pop up in interviews. They're also just a bit of fun as well. So if you're interested in math programming, or you just want to sit around with a bunch of people, eat free food, and have a bit of fun, come along on Saturday. Lots of free merch, free food, and yeah, something to do on the weekend. But apart from that, thanks, Hamish. See you guys next week for the talk, or on Saturday for CodeJam.
Awesome.
Okay.